Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
You know, from the quiet hum of a massive server farm to the absolute roar of a jet engine, there's this tiny, incredibly powerful force at play that makes it all possible. So today, we're going to pull back the curtain on one of the most crucial but totally overlooked pieces of modern engineering, the roller bearing. Let's see how these little things literally move our entire world. I mean, just look at these incredible machines. You've got the blades of a wind turbine, right? Each one weighs several tons, but they spin almost effortlessly in the wind. Or think about the landing gear of a jumbo jet, supporting hundreds of thousands of pounds when it touches down, and then it just retracts smoothly. Well, bearings are the unsung heroes that conquer friction and make all that massive movement possible. So what is this tiny marvel of engineering that carries such a huge responsibility? How does it manage to defy one of the most basic forces in physics, friction, to keep our whole world moving? Well, let's dive in. To really get the power of the roller bearing, we first need to appreciate its brilliant and, elegantly simple purpose. It's time to take a closer look at this unseen machine. Okay, so at its heart, a roller bearing is basically a friction killer. That's its whole job. It's this beautifully engineered device designed to replace the grinding, energy-sucking force of two surfaces sliding past each other with the smooth, super efficient motion of rolling. It's all about making movement as easy as possible. So how does this one little device pull off such a huge task? Well, the principle behind it is surprisingly simple, but it is profoundly effective. Let's take a look at how these bearings work their magic. Think about it like this. Imagine trying to drag a heavy refrigerator across your kitchen floor. That's sliding friction. It's super tough, it generates a ton of heat, and it wears everything out. Now imagine putting that same fridge on a little dolly with wheels. That's rolling friction. The difference is just night and day, right? Well, bearings are just the super precision-engineered version of that dolly, designed to swap that awful sliding for incredibly low resistance rolling. This whole brilliant idea comes to life with 4 key parts, and they all have to work in perfect harmony. So you've got the outer ring, which usually just sits still inside the machine's housing. Then there's the inner ring, which spins right along with the axle or the shaft. And sandwiched between them are the rollers. These are the real workhorses, the parts that carry all the immense weight. And finally, you have the cage, which plays an absolutely crucial role in keeping everything from falling apart. And this analogy just nails it. The cage's job is perfectly described here. It doesn't actually carry any of the load itself. Its only job is to be the traffic cop. See, without it, all those little rollers would just bunch up and crash into each other, and the whole thing would fail catastrophically. The cage makes sure every single element rolls along smoothly and evenly, allowing the bearing to do its thing. But, the world of engineering is full of all kinds of different challenges. That means you can't just have a one-size-fits-all bearing. So engineers have come up with a whole family of specialist bearings, and each one is masterfully designed for a very specific kind of job. Now, to get these different types, you first need to know about the 2 main kinds of forces or loads they have to deal with. First, you've got a radial load. This pushes down on the bearing, kind of like gravity. Think of the entire weight of a train car pressing down on the axle of its wheels. Then you have an axial load, sometimes called a thrust load, which pushes sideways against it, like the incredible force of a propeller pushing a ship forward through the water. All right, let's meet our first specialist, the cylindrical roller bearing. And as you can see, its rolling elements are, perfect cylinders. This simple design choice gives it a very specific and very powerful superpower. Because of that cylindrical shape, these rollers have a long line of contact with the rings on either side, and that's what gives them their incredible strength. It's the ability to handle absolutely massive radial loads, even while they're spinning at crazy high speeds. They're built for pure, brute force downward support and velocity. Okay, now let's check out a bearing with a completely different design, the tapered roller bearing. You can see right away that both the rollers and the rings are shaped like sections of a cone. And that's not just for looks. It's a little piece of geometric genius that gives it a really unique advantage. Yep, that conical shape is the secret sauce. It lets the bearing handle a combination of both heavy radial and heavy thrust loads at the exact same time. This makes it the ultimate versatile all-arounder, perfect for complex forces coming from multiple directions, like the ones you'd find in a car's wheel hub. And the family of specialized bearings just keeps going. You've got spherical roller bearings that have these barrel-shaped rollers that can pivot, which allows them to handle situations where a shaft might be a little bit out of line. And then you have needle roller bearings that use these really thin, long rollers, making them perfect for compact designs where every single millimeter of space counts. There really is a bearing for every single engineering challenge out there. So, given the incredible forces and extreme conditions these little components put up with, you'd probably think they must fail all the time. But the truth about their lifespan is actually pretty surprising, and it tells us a whole lot about the quality of their engineering.
What do you think this number represents? This isn't a failure rate. No way. In fact, it's the exact opposite.
That's right. An incredible 90% of all roller bearings will actually outlive the machine they are a part of. They are engineered to be so durable that they'll probably still be working perfectly long after the rest of the machine has been retired and sent to the scrapyard. It's amazing. So what about that other 10%? Well, when a bearing does fail early, it's rarely because of a defect. The main culprits are almost always outside factors. Tiny bits of dirt getting past the seals, using the wrong kind of grease, a sloppy installation, or pushing the machine way beyond what it was designed to do. The only other major cause is just simple metal fatigue, which is basically the bearing finally reaching the natural end of its incredibly long life. So when you really think about their durability, their versatility, and just how common they are, you start to see that our entire modern world is, quite literally, a world built on rollers. I mean, they're everywhere. From the complex systems that move cargo onto airplanes to the engine in your car, from massive hydroelectric turbines that generate our power to the precise medical scanners that save lives, from the hardworking tractors that feed the world to the solar panels that track the sun across the sky, all of it, every single bit, depends on the simple, brilliant idea of the roller bearing. The roller bearing is the perfect example of a piece of technology that's so successful, it has become completely invisible. It's this quiet, reliable workhorse that just does its job, day in and day out. It makes you wonder, doesn't it? What other engineering marvels are out there, hiding in plain sight, just silently and dependably making our world turn?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.